As per my introduction, as we know, coal is a primary resource of fossil fuel used worldwide for energy consumption as well as coking coal. To produce coke for iron and steel production, naturally occurred coal contains organic and inorganic matter, which requires substantial cleaning process before the coal can be utilized for industrial applications. Fine coal particulate matter present in the naturally occurred coal could be utilized for environmental and economic benefits. Hence, the separation of fine coal is very much essential. Numerous fine coal separation methods have been developed by a gravity separation, flotation, but the flotation technique is an effective separation method for fine coal based on the different surface hydrophobicity between the organic matter and mineral matter. Hence, here we can see the market size of coal in India, which is in steel industry, it is around 29.40%. Here is a diagram of range of conventional mineral processing techniques which shows that float flotation is the most successful technique. The float flotation diagram shows that how the collector is attached to the air bubble and coal and how the collector is then attached to the coal. Float flotation is widely accepted beneficiation process of for coke fines. The reagents required are floaters and collectors. As we can see in the diagram, without collector, the pores filled with water gets when it is interacted with the air bubble, it gives hydrophilic surface. But when with collector, pores filled with water gets into the coal surface and it forms a hydrophobic surface. Here is the literature review of evolution of reagents. Earlier, traditionally, we used hydrocarbon oils for coal protection. As these oils are hydrophobic in nature, they easily get absorbed on the surface of coal mines and increases the hydrophobic nature of coal mines. As hydrophobicity of coal mines are not sufficient for the effective protection of coal, that's why we need collectors to increase the hydrophobicity of coal mines. Then we used oil-based surfactant, but here the it enhances the flotation recovery, but large amount of reagents were applied. Then biodiesel came. Here it is the better efficiency, but as the age increases, the ash content also increases. Then the microemulsion comes. Here the sufficient efficiency at lower doses is good, but the selectivity requires further improvement. And in nanoemulsion, improves it improves simply and reduces the cost of process, but a large amount of surfactant and co-surfactant is required. So, to get the required collector, we need patch absorption where the yield percent is less, but our target is high absorption to increase yield percentage. So, my idea is using the superhydrophobic compound collector. My resources would be coal tar, anthracite, graphite, and graphene. But I will use graphene because graphene shows the better efficiency and better contact angle than the rest of the other carbon resources. Here is the molecular architecture of coal with the graphene. As we know, the American coal is having problem with high sulfur, but Indian coal we are trying to reduce the ash content. Even after washing the coals, the ash contains around 30 to 35%, which is very much. So I will be using nanoparticles with the nanoparticle as addition with the current collector. So it is will be compound collector and the superhydrophobic nanoparticles will get attached on the collector very efficiently, on the coal very efficiently. So this compound collector will work very nicely. The theoretical base shows that hydrophobic particle gets absorbed on the surface of coal, but hydrophilic gets absorbed. And hydrophobic surface has big contact angle. Smaller nanoparticles cover more surface area, and softer nanoparticles have a larger contact area, giving stronger addition resulting in higher flotation. So methodology is literature review, selection of compound collectors, synthesis of process of collector, and literature based result. So how these graphene nanoparticles will be made? Kish is a general term for the waste material that collects at the surface of molten iron after it is tapped from blast surface. At tapping temperature, the liquid iron is saturated with dissolved carbon. As the carbon cools during tapping and transported to the steel shop, it becomes supersaturated and carbon comes out of the solution as flakes of graphite float to the surface of iron. The hot metal is usually transported from the blast furnace to the steel shop in a refractory lined torpedo ladder. The longer the hot metal is held, the greater the cooling and the greater the yield of graphite. So from here we get the graphite flakes. And as we can see in the methodology, as per literature, in this way the beneficiation of so after the synthesis of nanoparticles, we can go with the characterization and then the dispersion properties and then with the flotation properties. Then cold flotation have some mechanisms like pillar effect. Then there is a characterization of these carbon particles, like how carbon particles react with this coal. And last, I have the conclusion that waste nanoparticle addition can be successfully used as collector to improve the yield percentage, minimize adverse effects on the environment due to utilization of harmful carbon particulate will be reduced, and nanoparticle collectors are commercially available in the market. Thank you, and these are my references.